All right. All right, we're going to get going. Hello, thanks for joining our session. I'm Patrick Kremer. I'm a staff cloud solution architect selling a VMware Cloud on AWS with VMware, and I'm joined by Steve.
Yeah, I'm Steve Barron. I'm a senior solutions architect with VMware Cloud on AWS. Thanks.
And you should be here for code 2742, Tales from the Trenches, real world VMware Cloud on AWS migrations. So today we are going to talk about two different flings that we've used to help our customers migrate into VMC, the SDDC Import Export Fling and the PyVMC Fling. They're both Python based, they're both open source. The SDDC Import Export is really designed to do kind of exactly what it says. It will take an existing SDDC that you've configured however you like. It'll dump that network config into a set of JSON files, and then you can turn around and import that back into a greenfield environment. It can also do synchronization. So you can set up the Fling to point to a source SDDC, and let's say you want to keep like VDI firewalls in sync, VDI firewall rules. You have a bunch of VDI farms. You can synchronize them with the Fling. It supports, all the major network objects in the SDDC, compute gateway, management gateway, distributed firewall. It can do NAT. It can remap public IPs. It can even synchronize CSP rules. So if you have a large number of users that you need to grant access to and you want to automate that, it'll do that. The PyVMC command line utility is really, it's a CLI for VMC, and it's used to abstract the raw API. Not a lot of people know how to call a raw API. So it's got a bunch of examples on how to do it. It's got a bunch of different commands to be able to manipulate the SDDC. It manipulates mostly the same objects that SDDC import export does, but it's really designed for you to be able to change your existing SDDC to change a configuration. So for the first little demo here, I'm going to give you a little preview of a hands-on lab, HOL 228704. This is the automation lab. So this is an ISIM that I recorded that actually takes you through how you would use the SDDC Import Export Fling. So the first thing you have to do, you always have to generate a token. Every API operation that you perform, you have to generate a token. So this shows you how to generate a token. Now in this example, we're giving it all roles, and now you generally would want to scope it down so that it is just VMC. You probably wouldn't give it org owner, but for the purposes of a demo, we just did it. You copy this big long string, which is an API key. And then really there's only 6 bits of information to make this Fling work. You need a refresh token for both your source and destination. And then you need the source and destination org ID. So you'll paste all that in, and here in your SDDC, the support tab, this is where you get the source and destination org IDs. So you'll snag those and paste them in here. And then in your destination, it's the same thing. Now we're running through here and we're showing, here's our source SDDC, and it's got a bunch of segments. It's got a VPN configuration. It's got some NAT configuration. Both the compute and management gateway have rules in them. And it's got a couple DFW rules. You've got your groups. So to actually run it, we just do Python SDDC import export and -o, your operation is export. And it rolls through all of the rules and it dumps them out into JSON. So it takes all the rules and drops them into JSON. Then we're going to turn around and we're going to go to the blank SDDC that we're importing into, and we have to do the same thing. We have to copy the org IDs in, and we also have to get a refresh token. Now, if you are going between SDDCs in the same org, you can use the same token. But if you're crossing orgs, that's fully supported too. You just need a token for your destination org. We're going to save it. And this is just proving that our SDDC is blank. There's nothing anywhere. There's no nats. There's no groups. So then you run the import command, which is down here. So instead of -o export, it's just -o import. It's going to warn you, hey, I'm running in live mode. Do you really want me to write objects to your SDDC? It'll loop through. Your the JSON. And then if you do a little refresh, everything is there. So your segments match, your VPN matches, the NAT rules almost match. What doesn't match is you can't copy elastic IPs, public IPs between SDDC. So it'll do a remap. It'll make a new NAT with a new set of public IPs. But it's all there. So that's the basic demo of the service. Now, a few different ways that customers are using this. So there's a config JSON. So here in the code, there's this config ini file that has a bunch of different ways that you can configure the Fling to work. One thing that you can do is you can do a true false. You can turn on and turn off any of the supported sections. So if you only want to do management gateway, you could shut off the compute gateway. You could shut off the distributed firewall. So you have that level of flexibility in the Fling. You have the ability to do an on-prem NSX DFW. So you can actually point the Fling to an existing NSXT distributed firewall, export that DFW configuration, and then turn around and import it into VMC. So this is great for someone who already has NSXT on-prem and you want to bring the distributed firewall rules over. I talked about a little bit about the selective sync. We have customers using it for Horizon clusters. We have customers using it for web farms. There's an S3 option too in here. So by default, the JSON gets written out to the file system wherever you run the Python, but you can actually configure S3 as an export type. And if you also configure this in AWS.ini, if you give it a bucket name and an access ID and a secret, it'll drop the JSON out to S3. We have internally, a lot of people are using that for lab scenarios. So we have a bunch of lab scenarios where the lab gets reset to an original config. VCDR, this is a configuration that we added. So there's regular expressions in there. You can exclude specific networks from import. You can do compute and management gateway. And firewall actually rules. So there's options in there to exclude it. We have it pre-populated for the networks that you do not want to import for a VCDR use case, because VCDR creates networks on the fly when it connects to a recovery SDDC. So you don't want to overwrite that. But we have customers using that for various reasons. Maybe you only want certain networks to come over. Maybe you only want certain firewall groups to come over. So you can exclude certain ones with regular expressions. There's also folder sync. So we have some customers that need to migrate over and they have just like a monstrosity of an on-prem vCenter configuration. They've got folder after nested folder and they don't really want to do it manually. So you have the ability in, if you configure vCenter ini, you can dump that out to a file and then turn around and import that into your VMC vCenter. So it just saves some manual work. And I think the last thing that I'm going to highlight is this very important one. If you are playing around with this and you're testing it out and you have a VPN configuration, as soon as you import it, it's going to try to turn on. And if your VPN is set up like our lab is, it's just automatically going to come up. And then your actual live VPN is going to kind of blow up. So I took down production this way when I first was testing out the SDDC import export. So I added that little feature. So if you flip that to true, it'll import your VPN configuration, but it will not turn it on. So I highly recommend that. That is a feature if you're going to mess around. All right, that's it for the quick intro. And now on to Steve.
Thank you, Patrick. Quick question in the chat. Do you support SDDC groups within your import-export Fling?
Oh, SDC, not yet, right? That's a goal. That's a target that we're trying to hit for M16, but we're all volunteers, so it's a fling. So no SDDC grouping yet, but
I just want to make sure we tied off that question before we moved on. So
yeah.
Then as we move into the next phase, we're going to start walking through the PyVMC client for as the Fling for VMware Cloud and AWS. And one of my customers had a challenge of moving an entire data center from into VMware Cloud on AWS, and migrating the virtual machines is pretty easy with HCX, but migrating some of the layer 4 through 7 firewall rules could be a bit of a challenge, especially if you're coming from non NSXT environments into VMware Cloud and AWS. And in their case, they were a Cisco ASA customer. A typical firewall design is more of a hub and spoke network. Segmentation is done through layer 3 and 4 routing protocols, right? And the firewall sits in line between the different segments of an environment. With an NSXT distributed firewall, it's distributed across the entire SDDC. Security policy enforcement is performed at various gateways or distributed firewall or the virtual network adapter or the virtual machines. As the SDDC scales out, so does our NSXT configuration. So we get more capacity as we add additional hosts within the traditional firewall design. We're going to be pretty limited as far as what our throughputs can be, depending on the size of the box that's sitting in line. But that all being said, when you're migrating from one firewall type to another, there's some configuration work that has to be done. It's kind of a journey that my customer went through. I went ahead and built out a lab environment to show this off. This shows 6 different networks that we're going to be migrating into VMware Cloud on AWS. I want to show this pretty quickly. This is what my configuration actually looks like. I got all my interfaces, my object groups, network groups, groups of groups, and then ultimately my access lists, right? So pretty standard stuff that would be needing to be migrated as we migrate the layer 3 and 4 gateways into, or the layer 3 gateways and layer 4 firewalls into a VMware Cloud and AWS. We have to consider the security has to come with the migration. So the first thing we're going to do is build the segments. I have the original config in the slide here below, and then what the Python client commands would be. So we're always going to call the Python script. We're going to use the command. In this case, it's new network. We name the network. We define the type of network, and then we're going to use the CIDR range and the gateway address with the CIDR notation. So in this case, there is a little bit of manual conversion to be done between a netmask notation into the CIDR notation, but you can see how going through programmatically, I can take these 5 or 6 lines per interface and basically rewrite it as a single line within the PyVMC command. Once we have the interfaces built out, the next typical thing that I was going through is building out the groups. And there's 2 different types of groups within the PyVMC client. They can be IP based, so you can create groups based on individual IP addresses or network ranges, things like that. You can also have group based memberships. You can have groups of groups, and criteria based being depending on, for instance, the name or notation within the name of a virtual machine. In this case, there's a couple different examples in the ASA configuration. This is what a typical network object looks like. We're going to map the network object name into the group name field. We're going to map the network object range into the members field. And in this case, the members field is a comma separated value. And you can see, again, I'm having to make the conversion between netmask notation and CIDR notation. The other example is an individual IP command within the object group of an ASA configuration uses the host command. And in this case, we would just map that directly to the members. Once we have the segments built, we have some of the groups built. Next, we can also build groups upon groups. So this is a pretty common scenario within ASAs to have group-based membership. You can see this in the network, the object group network with an object, with a group object as a member. Again, same things apply. We're going to use the script and the command. We're going to define the we select the type, whether it be management gateway or compute gateway. In most cases, it's going to be compute gateway. We map the group name, and then instead of choosing IP based for the parameter for the group type, we would choose group based. So the prerequisite is that the member groups are going to have to exist before you can build the groups of groups. Once we had the next step I walked through was building service groups, and the service group parameters in the Python VMC client are not kind of they're not line driven the way that the other commands are. They're actually prompt driven. So I just kind of took an example of the command is PyVMC new service, and you get some inputs that you're asked to put in. And this is because the way the services are built on nested service objects. This is the way that the tool is collecting that information. So you're going to put in the name of the service, define an entry ID, which is just a variable. You select the layer 4 protocol, and then you start adding your ports. And then when you're done, you click done, and the output is the result at the bottom. So a lot of our customers, a lot of Cisco, engineers will have this pretty well defined and built out into their code. So, building things into services and service groups is important. It should be noted too that there's a lot of already predefined standard services that are built into the NSXT configuration. So you don't have to go through and build out HTTP and HTTPS and database type services. So once I have my groups, once I have my network groups and my service groups built, the next phase would be to build my ASA or my access lists, and that really comprised of the compute gateway and the distributed firewall service within VMware Cloud and AWS. So there are a couple scenarios that we have to consider. One being that because of the difference in architecture between the traditional firewall and the NSXT configuration, we have to kind of split and delineate the work, where the rules and policies are applied to. So the compute gateway firewall is going to basically be your your north-south traffic into and out of the SDDC, whereas your distributed firewall policies are most often built to configure that intra SDDC communication, effectively allowing and blocking traffic between virtual machines in the SDDC. So we have to make the decision as we go through the ASA access list to define whether or not where we need to put those services. And so we're going to start with we're going to review the ASA line. The question is, will the source and or destination reside at VMC? If the answer is yes, then are both of them going to be in VMware Cloud and AWS? If the answer is yes, then we have to use the distributed firewall section. If the answer is no, then we potentially could and should use the compute gateway firewall instead. So the other consideration is as you go through an ASA code, it's potentially that the Cisco administrators will not have put in defined names and groups of resources into their code. So we might have to go through and additionally add in additional groups as we go through the ASA access lists. Distributed firewalls are broken into categories, sections, and rules, and I just want to point that out because we have to define, we have to predefine the sections. The categories are defined for us. We have to define the sections before we can define rules. So in order to create the firewall sections, I don't exactly remember what I was trying to call out here. Once we have the sections built out, it's one of the parts of building out the distributed firewall rules is we're going to have to put it into a section, and so this is probably a little complicated, but in the DFW sections part of this screen where my mouse is, we define the new sections, and then those sections have to be put into the new DFW firewall rule command. So in this case, we're creating a firewall rule called ICMP allow. We've created groups called RFC 1918 for source and destination. The services already existed. They were predefined in the NSXT configuration. We set the action, and then we define what section we want to put that in. So the sections have to exist before you actually create the rules. And then at the bottom, I have the access lists broken out and kind of mapped to where they would go into the different, into the DFW rule configuration. Same thing applies for the gateway firewall rules. We're going to take the permit or deny, that gets mapped to the action field. We have the source and the source fields get mapped to the source groups. The destination fields get mapped to the destination group, and the services get mapped to the services section. So again, with the caveat being with the compute gateway firewall rule, there's no sections per se, but there is a scope, and scope can be set to either all. Long and short of it is there's four different interfaces on that the compute gateway firewall rule can be applied to. It can be across the cross VPC, public internet gateway, VPN connections, and the direct connect interface. So you can set it to all or any of those, or one of them, or specifically wherever you're trying to block or allow traffic from. So at the end of the day, we end up with something. I'm going to flip back over to my screen. We ended up with something that looks more like this. So we took this ASA configuration, which was 311 lines, and I've excluded quite a bit of the stuff that doesn't need to be imported, and we end up with a list of commands that looks something more like this. And once we have this kind of ready to go and formatted, let me flip back over. Once I have this created and formatted, I'll just show this. Like for instance, in my segments field, this is a VMC console here. I got none of my networks, but I can very easily just take this, copy it, paste it into my terminal. It's going to keep adding these to my SDDC. And once again, we're gonna have to put this in programmatically, and we have to have the prereqs put into the SDDC before we can build the next level set services. So we have to build the segments, then we have to build the groups, and then the groups of groups, and then ultimately we could do the DFWs and gateway firewall rules. So I'll flip over, flip back. We should start to see these. Yeah, here's all my segments have been populated. So while getting it set up and kind of initially, and the initial state could take a little bit of time, at scale, when you're talking about 1,000 ACLs or dozens or hundreds of groups, it could become very effective to kind of programmatically go through this, rewrite this into the Python client, and then import it into your SDDC, rather than your alternative option might be to click add segment, type in a bunch of information, click save. This is also going to be a little bit, I think this will be less error prone because you get the chance to validate some of this stuff before you actually put it in. And if there's an error, it will spit an error out as well, rather than the success information that you're seeing on the screen right here. And that's pretty much it. We can keep going through this, but right now it's just basically copying and pasting and putting information and building out my configuration.
So Steve, how much experience did you have with the VMC API prior to jumping into this with your customer?
Not much, actually not much at all. This was one of the benefits of the PyVMC client is it kind of defines, it pointed me in the direction. It was a very ambiguous part of my knowledge base around the service, but being able to read through the PyVMC client was really helpful. As an example, there's a show SDDC command that my customer asked about, and I didn't know anything about it, but they were asking some questions about this host command. And I was able to find, I look and I search through the client and I find this host command. It's like somebody had already figured this out. So it's basically, a way of documenting the API for me. So I don't have to know that much, but now I can kind of search into my function, see what the function does. For instance, this function here, this get CDC host, is pulling this URL, right? So I didn't know anything about this, but now I can get into the URL and look through the VMC API orgs, find the tenant SDDCs, and I can map that directly into Development Center, which I used to just have to kind of hunt and poke for this type of information, but now with the Python client, it's pretty well documented for me. Most of what we actually might need would be here. Let's pull this real quick. So I can probably logically map this to orgs, SDDC, SDDCs right here. And this is the same. So this API, this API call, right, is pulling directly from here. And now I can actually execute it here as well. And this is what it logically returns, right? So, and you and I talked about this. It's we return a subset of information that we think is relevant, but you can see here based on the SDDC command. There's availability zone information. There's all sorts of cluster information. There's ESX host info, right? There's the bare metal infrastructure side of things. We can pull ENI information. It's all readily available to you, and I'm pretty easily able to modify these. A lot of these commands to suit my needs. Here's an example, right, of things that I was able to look for because I was looking for availability zone info for a customer.
So we got about 4 minutes left. Feel free to hop off mute if you have specific questions. There's also a reminder to please take your session survey. We have no idea if we're hitting the mark or if you would like something else next time, or whether this is good content that you want to see more of. So please give us feedback. It's the only way we know what to do next. All right, I don't think we have any questions.
Well, I've got one. Is this more applicable for a, let's say, a full migration rather than a hybrid environment, or is this something that we could kind of pair some of these firewall rules that are present on premise and use them in the SDDC to kind of make a tighter security internally? If an app needs to talk to a different server that I've migrated to the SDDC versus in a hybrid environment where it might need to talk to on-prem.
I don't think the intent would be to keep like it in sync, for instance, but as you go through, maybe, if you have a pipeline in which you're, developing code, deploying code, and then also deploying your firewall rules today, using the PyVMC client, or even just the API calls within the client itself would give you, you could inject that into your CI/CD and say, where depending on where you deploy your application, here's where I'm also going to deploy the security alongside of my application.
Thanks.
The chat question is recording. Kripa, I don't know if you're in the audio. Are the recordings actually going in there?
Yeah, it's going on still.
What'd you say?
It is getting recorded. We're going to post it to the Code YouTube channel when we're done.
Awesome. Cool. Thank you.
All right. Well, thank you all for joining. And again, don't forget to take the survey, and we will keep putting out good content.
Thanks, everybody.